Using the compound angle identities, find identities for sine 2 theta, cos 2 theta, and tan 2 theta. These are known as the double angle formulae. So if we now go back to using the sine of theta plus phi is equal to sine theta cos phi plus cos theta sine phi, and let theta be equal to phi. So everywhere there's a phi in here, we're now going to replace it with a theta. We now get sine of theta plus theta, which is sine theta cos theta, and then cos theta sine theta. That now gives me two lots of sine theta cos theta, and theta plus theta is theta plus theta is 2 theta. So we get sine 2 theta is 2 sine theta cos theta. For part B, if we use cos of theta plus phi is cos theta cos phi minus cos theta sine phi, and again let theta be equal to phi, then we get cos theta plus theta is going to be equal to cos theta. This now becomes cos theta minus sine theta sine theta, which gives me cos 2 theta is going to be equal to cos squared theta minus sine squared theta. Now from this we can actually derive two more. So if we now use cos 2 theta as to cos squared theta minus sine squared theta, we'll call that equation 1. We know that sine squared theta plus cos squared theta is equivalent to 1. Therefore, sine squared theta is equivalent to 1 minus cos theta, and cos squared theta is equivalent to 1 minus sine squared theta. So if we now substitute sine squared theta is equivalent to 1 minus cos squared theta into 1, so wherever there's a sine squared, we now replace it with that. So we've got cos 2 theta is cos squared theta minus. Now because we've got minus, we need to put this in brackets. 1 minus cos squared theta. So it gives me cos squared theta minus 1, minus a minus gives me a plus cos squared theta. Cos squared theta plus cos squared theta gives me two lots of cos squared theta minus 1. And also if we substitute cos squared theta is equivalent to 1 minus sine squared theta into 1, we're going to get cos 2 theta. Now instead of cos squared theta, we're now going to put 1 minus sine squared theta, and we've still got that minus sine squared theta on the end. So that gives me 1 minus 2 lots of sine squared theta. So for cos 2 theta, there are actually 3 different formulae. Finally, to do tan 2 theta, so we're going to use tan theta plus phi, tan theta plus tan phi over 1 minus tan theta tan phi. Again, we let theta equal to phi, so we get tan of theta plus theta is equal to tan theta plus tan theta over 1 minus tan theta, which gives me 2 lots of tan theta over 1 minus tan squared theta is equal to tan 2 theta. So writing them all out, and it's worth trying to actually learn these. You get sine 2 theta is 2 sine theta cos theta. Cos 2 theta is cos squared theta minus sine squared theta, or equal to 2 cos squared minus 1, or 1 minus 2 sine squared theta. And we have that tan 2 theta is 2 tan theta over 1 tan squared theta. So like I said, it is actually quite worth your while learning these. This has been a video to show you how the double angle formulae are obtained. I hope you've understood, and I thank you very much for watching.